Hello everyone, welcome back. In this video, I will discuss the solution of the problem maximize the cut segments. Given an integer n denoting the length of a line segment, and you need to cut the line segment in such a way that the cut length of a line segment each time is either x, y or z, and here x, y and z are the integers which will be given to you, and after performing all the cut operation, your total number of segment must be maximum, and if no segment can be cut, then in that case we have to return 0. So let's see how we can solve this problem. So not just only in this problem, when you have to maximize something or minimize something, when you have to maximize something or minimize something, there can be only three possible solutions. The greedy approach, where you will explore only few state and claim that answer depends on only those states, and we discard the remaining states because answer does not depends on those states. So greedy solution. And if you won't be able to find any greedy approach that can solve your problem, then next check for a binary search. Apply binary search, and the necessary and sufficient condition required to apply binary search is a monotonic function. Find a monotonic function for your problem, and then simply evaluate the ranges of low and high and apply binary search. And if it is still not able to solve your problem, then we have to check for all the possibilities, that is recursion. And if there is some overlapping subproblem, then we can memorize it using some data structure, that is a dynamic programming problem. And it always helpful to follow the same hierarchy from top to bottom, because there might be a case when binary search or recursion solutions require some greedy observation. And for this problem, the length of the line segment initially n, the length of the line segment is n, and we have to cut this line segment, and each time we can either make a cut of x, or we make a cut of y. Let's say y is greater than x, and or we can make a cut of z, and we have to partition the entire line segment of length n. So here we cannot find any greedy approach because we do not know. Let's say you have cut the line segment of z from this initial line segment of length n, then there might be a case when you won't able to cut the remaining pieces. This remaining pieces you won't able to solve this remaining sub problem. So somehow we have to explore all the possibilities, that is a recursion. And also you won't be able to find any monotonic nature for this problem. So the next step that we are left with is a recursion. Try out all the possibilities and return the maximum answer. So let me define the function. So let's say f of n, or maybe I can say f of I. Yeah, that would much better. So f of I will simply denote the maximum number of cuts that we can make on line segment of length I, on line segment of length I. Cool. Then what will be the transitions? So for every line segment of length I, we have three possibilities, that is cut a line segment of length x, y or z. Cool. So f of I, perform one operation, and then solve the remaining subproblem, which is I minus x, and since we have performed one operation, so +1 for this purpose. Now tell me the maximum number of cuts that we can make on line segment of length x minus I minus x of length I. Yeah, this is the complete state and a definition of the state. And otherwise we can also make a cut of I minus cut of y, that is the remaining length would be I minus y, and +1, because since we have make one cut, and then the last one, which is I minus z, and again +1, and then tell me the maximum number of cut that I can make on a line segment of length I minus z. And this is a sub problem. Cool. And since our goal is to maximize this, so I will simply select the maximum of all the three possibilities, and this +1 is common in all these three terms, so we can take this outside. Cool. So I can write this +1 over here, and make sure that the value of I must be greater than or equal to z to make this call, and similarly a value of I must be greater than or equal to y to make this call, and the value of I must be greater than or equal to x to make this recursive call. And what would be our base case? So if value of I is equal to 0, that is a line segment of length 0, then it is not possible to cut it further. So I will simply return 0 in this case. Cool. And this is a base case. F of 0 is equal to 0. So yeah, this is the complete solution. Now let me just show you the implementation. So first I have declared an array of length n plus 1, and this is a DP array. of length n plus 1, then setting all the values to the minus 1. Okay, we'll tell you this thing why I'm setting all the values to the minus 1. Then this is our base case, dp of 0 is equal to 0. Then I iterate over all the line segments from 1 to n, and if the value of I is greater than or equal to x, then only we can make a cutoff length x. And dp of I minus x must not be equal to minus 1. If it is minus 1, then this means it is not possible to solve the remaining subproblem. It is not possible to cut the line segment of length I minus x. So that's why having its default value, which is minus 1, and if it is not equal to minus 1, then it means we can solve the remaining subproblem. So I am simply taking the maximum of dp of I that we have so far, and then dp of I minus 1, the maximum number of cuts that we can make on a line segment of length I minus x and plus 1, since we have performed one operation. And similarly, the same goes for y and z. And then after I am checking dp of n. So dp of n is equal to minus 1, then it means it won't be possible to cut a line segment of length n. So in that case, we have to return 0. It is mentioned in the problem statement, and otherwise we simply return this value dp of n, the maximum that we can make. And the time complexity is a linear, n number of iterations, and the space complexity is also linear, since we are using an extra space, which is this dp array. So let's just try to submit this. Successfully submitted. So thank you so much for watching this video. Have a good day.